Okay, so besides log base 10, which you have in your calculator, the second one doesn't look like an obvious log, but it's the ln button, and it's a log base e. E is kind of a number like pi. It has a specific value relative to the world. It's kind of like the half-life issue. It's the limit of how much money you can make, compound interest, which we'll talk more about later, continuously compounding. But it's a specific value, and we use it as the other base of logarithms. So when you see ln, it's a log base e. Similar to the properties of 10, if there's an e on your base and an e inside the logarithm, they will cancel because e is, again, just a number like pi. So evaluate the following without a calculator. The ln of e to the fourth, bring the 4 out. 4 times the ln of e. Again, the ln of e is log base e of e, which means it's going to cancel into 1, or reduce. This is 4 times 1, which is 4. Ln of 1 over e to the 7 halves. Division can turn into subtraction. Ln of 1 is 0. Ln and e will cancel, so it's 0 minus 7 halves, which is negative 7 halves. Ln of the fifth root of e, this is ln of e to the 1/5 power. Remember, roots turn into fractional powers. And again, the ln and e cancel, so this is just 1/5. Similarly to the log problems, if you have some that aren't exact like this, you may encounter them on your homework. You can type them into your calculator and just get a value, round to whatever it tells you to round to. So the ln of 142 is 4.956. If we're rounding to 3 decimal places, the ln of 0.005832, negative 5.144 in the calculator, and the ln of 2347 is 7.761, rounded to 3 decimal places. Okay, so the next question you might have, or maybe you don't, is what happens if I have to try to evaluate a logarithm, but it's not a log base 10 or a log base e, an ln? How do I put any of those in the calculator to get an approximation? Now, thankfully, we have what's called the change of base formula, and it allows you to convert out of a logarithm into another set of logarithms. So it's this log base a of x equals log base b of x over log base b of a. So if you have log base 3 of 7, obviously there's no log base 3 button in most calculators. You can convert it to log of 7 over log of 3. Whatever's inside the parentheses goes in the numerator, and your base goes in the denominator. And you can use log or ln. Both of these will be the same thing. Log of 7 over log of 3 is the same as the ln of 7 over the ln of 3. So you can choose whichever one. Just make sure that you choose the same one both times. So the log of 37.2, base 37.2 of 456.78, says just rewrite using the change of base formula, don't evaluate. This is the log of 456.78 over the log of 37.2. Log of 0.034, base of 0.034 of y, is the log of y over the log of 0.034. And again, you can use ln instead of log. It works the same. Log base x squared plus 3 of x to the 5th plus 2x plus 1 is the log x to the 5th plus 2x plus 1 over the log of x squared plus 3. Now, examples where this is useful. Evaluate the following using a calculator. Log base 5 of 17. Obviously, you don't have a log base 5 button in your calculator, but you know that you can do log of 17 over log of 5, and this allows you to use the buttons that you have in your calculator. So what is the log of 17 divided by the log of 5? It's 1.76. Log base 2 of 0.01. Again, I can do the log of 0.1 over the log of 2. Put it in the calculator. This is negative 3.322. Lastly, log base pi of 47. That I can do as well. Log of 47 over log of pi. That is 3.363. So from here, we just have a few more applications of logarithms in E. So as a reminder, we talked about this a few days ago, but remember logarithms and exponentials are inverses, so not only can we simplify equations with logarithms on the outside, we can now simplify equations where exponentials are raised to logarithms as well. So not only is the log base 2 of 2 1, 2 to the log base 2 power is also 1. So when we have something like e to the ln of 4x, this e and the ln are inverses and cancel each other out, so the only thing we're left with is 4x. E to the ln of 54, again, e and ln cancel each other out, so we just left with 54. Finally, e to the ln of 1 over e to the 4th. You might think, well, I see e's there, I'm going to cancel all of them out. 1e cancels out 1 ln. It's like you can't have a square root and like force squareds underneath it and cancel all of them out. So this e and ln can cancel each other out. So we're left with 1 over e to the 4th. You could also have canceled out the other set by doing a few things, but I think it's easier to cancel out the outside ones. And lastly, plugging in values to functions. Given f of x equals ln of x, evaluate at the following points. E to the negative 1/2, f of e to the negative 1/2 equals the ln of e to the negative 1/2. And what do we know about ln and e? They cancel, and we're left with the negative 1/2. E to the x squared, so f of e to the x squared is the ln of e to the x squared. ln and e cancel, and we're left with x squared. Even 1 over e to the pi squared plus 3 pi minus 2. I'm going to write f of that thing and just draw the arrow. So it's the ln of 1 over e to the pi squared plus 3 pi minus 2. Now what do we know about ln's when there's division? You can subtract the ln of 1 minus the ln of e to the pi squared plus 3 pi minus 2. ln of 1 is 0. ln and e will cancel, so we have 0 minus, in parentheses, our exponent, pi squared plus 3 pi minus 2. Because we're subtracting it, it changes all our signs, so this is equal to negative pi squared minus 3 pi plus 2. And that is all for 4.3.